one of the things I really appreciate about classical education is that the pedagogy teaches different types of material differently, right? So we're not just going to teach all of knowledge as this big undifferentiated mass of facts that you need to know. And I think in math, it's critical to break out grammar, logic, and rhetoric, because you need to teach each of those three disciplines of thought differently. When you're teaching grammar, that is, when you're teaching the students to manipulate expressions, it's rote. You need to know your multiplication tables. You need to be able to divide fractions. You need to be able to do it perfectly every time, and it needs to be like breathing. Just like when we're writing an English word, we don't need to think, how do I write the letter P again? I don't remember how Q works, right? If you have to think about that, you'll never enjoy writing. When you learn the grammar, you need to learn that very precisely as rote so that you can do it automatically. So sort of that's the inner core of mathematics. When people have the debate, do we need to teach abstract concepts or do we need to teach sort of concrete real-world applications? Well, the answer is yes. We need to teach both of them. But I think people are confused about what's concrete and what's abstract in mathematics. It turns out, bizarrely, that word problems are very abstract. That is, they require abstract thinking. And what we would think of as abstract, right, the sort of, here are a bunch of numbers, manipulate them, that turns out to be very concrete. And I think that's the opposite of how most people understand it. If you ask someone to divide two numbers, there is a concrete procedure that you can follow to divide two numbers. It's always the same. It's long division, right? You learn it as a child. You learn how to do the long division procedure. It's very concrete. You could make a dance out of it. I mean, you could have the hokey pokey of long division. You take the number in front, you see how many of them go into this, you write the number up here, you multiply it by that, you put it down at the bottom, you keep doing that, right? It's a procedure. It's very concrete. That's the grammar of mathematics. I really do think that's surprising. I think people are backwards about what's abstract in math. We tend to think of word problems as concrete because they have things like apples and monkeys and orangutans in them. No, that's terribly abstract. Because what a word problem forces you to do is it forces you to bridge kind of a linguistic divide between the world of objects and things and concepts and ideas and this world of mathematical notation. And that's a very synthetic skill. It's a very hard skill. It's something that takes thought, it takes time, it takes effort. It's very abstract. So I think when we teach mathematics, we need to proceed from the concrete to the abstract, which bizarrely means we need to proceed from teaching kids sort of the rules for how to manipulate mathematical symbols, kind of that's the tight core of what we teach. When we teach students logic, we want to teach them how to assess, how to evaluate the expressions that they've learned when we taught them grammar, right? We want to teach them the rules that govern what you can say with the new tools we've given them. That's a little bit more abstract, right? The rules there aren't quite so cut and dry. If you have an equation that's got complicated things on both sides, and you want to have just y on one side of that equation, there's not always an identical rote procedure you can follow. It takes a little thought. It's abstract. Similarly, when we ask the students to embed that logic and that grammar in a broader rhetorical context, that's an enormously abstract skill. And it's one that we need to give students time for. It's one that we need to help them with without telling them how to do it. And that's very challenging as a math teacher. It's very tempting when the students are working on a word problem to say, here's how you do this word problem. Well, that does them a disservice, right? Because they'll never learn how to think them through themselves. Instead, the students need to take the time, to take the effort, to think through what logic, what grammar applies here. It's as if you were teaching someone to play chess. And first you teach them how the pieces move, right? Then you teach them the rules about how to win, right? To win, you have to put the king in checkmate. You have to get it so that the king can't move and would be taken. And then at a certain point, you have to teach them the strategy of how to play. Well, imagine if you went to teach someone chess strategy, and what you did is you always moved the pieces for them, and they just watched you move the pieces. And then afterwards, you gave them the board and expected them to move the pieces the way that you just did. They wouldn't learn how to play chess. They'd learn how to play your game of chess, right? They wouldn't even learn how to play your game of chess. They'd learn how to parrot your game of chess. Imagine what would happen to someone who learned to play chess that way if they had to play a new game, if they had to play chess against someone they'd never played against before. That they would find themselves hopelessly unprepared for the strategy and tactics of it. Similarly in mathematics, once you've taught the kids the rules, once you've taught them how to manipulate those expressions, once you've taught them the logic of what mathematical statements look like, and how to manipulate those, and how to look at the rules of consistency and implication, you need to let them play the game. And that's messy, and they're going to lose sometimes, and that's normal. There are times when students will work a problem and they'll go down an entirely wrong path that doesn't lead anywhere. And we shouldn't punish them for that. We should reward them for that, right? As long as they go back and try another path.